We're always taught that things like logic and math are the absolute bedrock of truth. But what if their foundations aren't nearly as solid as we think they are? Today, we're going to dig into a really fascinating, kind of hidden flaw in how we reason, a concept we're calling halfway reasoning.
Right, think about it. Logic, reason, math. We see them as perfect, unshakable. They're the tools we use to build arguments that are supposed to be completely airtight. Totally certain.
But here's the big question. What if that bedrock isn't solid rock at all? What if our most careful, most logical arguments are in some fundamental way built on nothing more than a guess? Let's take a closer look.
So let's start by really examining that so-called foundation. We're told that math and formal logic are the gold standard, right? Where every single step follows from the last with absolute, undeniable certainty. But is that really the whole story?
And this brings us right to the core idea of this whole explainer. It's a concept called halfway reasoning. Think of it as a tiny, subtle crack that can show up in even our most solid-looking arguments. So what is it exactly? Well, to put it simply, halfway reasoning is when you start with an assumption. You don't really check if it's true, but you just go ahead and build your entire case on top of it anyway. It's literally like building a skyscraper without checking if the foundation can hold the weight.
And the process is, well, it's simple, which is what makes it so sneaky. First, you make an assumption you haven't really proven. Second, you start stacking your logical blocks on that shaky ground. And third, you get to a conclusion that feels totally solid, but it could be completely wrong because your starting point was never actually true. Now, you might be thinking this is just for, casual debates or something. But this little flaw can pop up in the one place you'd never expect it, the world of pure mathematics. Let's look at a couple of examples here. Okay, take a huge idea like infinity. A mathematician might say, all right, let's just assume this particular definition is true. Now from there, they can build a beautiful, perfect, logical proof that infinity exists. But the entire argument, the whole thing, rests on that initial let's assume. If that definition wasn't actually true to begin with, the conclusion just collapses.
And listen, this isn't just for these huge, abstract concepts like infinity. This crack in our reasoning can hide inside ideas that seem incredibly simple, things we just take for granted every single day. For instance, how about this statement? You can always add 1 to a number. I mean, that sounds about as basic as it gets, right? It sounds completely 100% reasonable. But if we actually poke at it, we find some hidden problems.
To make that simple statement truly bulletproof, you have to define everything. What exactly do you mean by a number? Are we talking whole numbers, fractions, imaginary numbers? What does always mean? Does this process go on forever? And what happens if you try to add 1 to something that isn't even a valid number, like the word blue? All of a sudden, that super simple assumption isn't so simple anymore.
And this gets us to the deepest part of the whole problem. It's not just about these specific little assumptions, it's about the very act of trying to define our terms in the first place. See, we love to imagine that reasoning works like the picture on the left. You have a solid foundation, you take logical steps, and you get a valid conclusion. Simple. But halfway reasoning shows us that sometimes it's a lot more like the picture on the right. You start with an unchecked assumption, and even with perfect logic, your conclusion is resting on shaky ground.
So this all leads to a really, really big question. If every single assumption we make needs to be defined and proven, and those definitions themselves have their own assumptions, how on earth can we ever build a perfectly closed, 100% proven argument?
And here's the ultimate twist, the real mind-bender. To build that perfect argument, you need a true starting point. But where is it? You have to define your terms. Okay, but to do that, you need a solid definition for the word definition. And to define that, well, you see the problem. It's an infinite loop. It's a snake eating its own tail. There is no perfect solid ground to start on.
Okay, so if perfect, absolute certainty is basically impossible, what are we supposed to do? Just throw our hands up? No, not at all. It just means there's a different way, a different mindset we can bring to the table when we reason.
And that key, that solution, is humility. It's recognizing that all of our reasoning, every last bit of it, is built on assumptions. And those assumptions are based on distinctions that we create, distinctions that might not be as real or as solid as we'd like to believe.
So the goal here isn't to achieve some perfect, absolute certainty, because that's probably off the table.
The real goal, the crucial point, is just to be aware of your starting assumptions. Know what you're taking for granted. Understand that your foundation is a choice, and it's your job to make sure it's strong enough to support what you're trying to build on top of it.
So, the big takeaway here isn't that logic is useless or broken. It's actually the opposite. It's that we need to be more mindful, more careful about its foundations. And that leaves us with a final question to really think about. What assumptions, big or small, are you reasoning with today?